Hello, Algebra 2, Chapter 2, Section 1. We're going to try to solve some equations this chapter. So today starts off with some easier ones. Tomorrow we'll work in some shortcuts. There's some word problems that'll drop in 3 days. But we're just trying to get you going again. So some of you have had a few classes and you've heard this speech a few times, but here's the ideas we're trying to stress today with equations. An equation is just any kind of a math sentence that has an equal sign in it. So the way I would encourage you to think about this is that an equation's like a scale, one of those old-time scales, where if you have a 7-pound item over here and you're trying to guess how much it weighs, and you put that on your scale, the scale goes clunk. Okay. If you came along and you tried to guess what that weighed, you put weights on this platform and try to bring it into balance. Like you might put a 10-pound weight over here, and then it would go clunk the wrong way, and then you know it's under 10. So you take the 10 off, throw a 5 over here, now it goes clunk again this way. But if you throw another 1-pounder on here, and another 1-pounder on there, balances out, and now you're 7. Equations are coming to you pre-balanced. Okay? This side is equal to this side. This equation is in balance. What we're going to have to do in math is always keep our equations in balance, which means if we do something to this side, to change this side, we have to do the exact same thing on the other side to keep that equation in balance. Okay, so that's a concept. These equations are like a scale, they're balanced, we need to keep them balanced. You'll do this in algebra, you'll do this in chemistry, you'll do this all the time. Okay? You're going to have to balance these equations. Whatever you do to one side, you do to the other. The other key thing in anything that has to do with algebra is you're always looking to do opposites. Everything in math has an opposite. Whether you're in Algebra 1, Algebra 2, trig, calculus, beyond that into college, whatever. Whatever math you learn, everything's going to have an opposite. You look at the calculator, you look at somebody's fancy calculator sometime, there's buttons on here that you have no idea what they even are. But every button on here has an opposite. No matter how big or how small these equations get, we can always try to solve them by doing opposites. So we're going to have to scope out the variable, we're going to see what it's doing, and we're always going to look to do the opposite. The other key thing about equation solving that's good to know is you can always check these by plugging the answer back into the original problem and just making sure that it does indeed work. Today, to emphasize these ideas, I'm going to make you show work on these equations. Now, can most people solve this without showing any work? Absolutely. Will I let you do that on this homework? Today, I will not. Tomorrow, would I? I absolutely will again. But for one day, what I want you to do is get hammered into your brain the idea of I have to do the opposite, I have to do the same to both sides, I have to check this thing. Those are just habits that we want to build to get reinforced in your mind through the homework. So if we go to solve this, the variable is subtracting, so what I'm going to need to do is add. On the notes page, you see a little note on there that says APE. There's a thing in math called the addition property of equality. People that have had geometry already have spent a lot of time last year working on the addition property of equality, which just says if things are equal, you add the same thing to both sides. So for this, if I see a subtract 3, I'm going to add 3 to one side. And then on the other side of the equals, I'm going to add 3 over there. If I subtract 3 and then add 3 in the same area, those just nullify each other. Those are going to erase each other. Variable's left standing, the equals is left standing, 8 plus 3 is 11, and then we could check that just to make sure. Put it in, 11 minus 3 is indeed 8, check. Okay, so on the homework page, what I want to see is what opposite did you do? Add, subtract, multiply, or divide. Is it on both sides? Did you check your answer? I should see a layout like that for every problem once these papers appear in my possession. There's also a thing called the subtracting property of equality. I put on the notes paper SPE for short. So you use that if the problem's adding. The equation wants to add, so we're going to subtract. We're going to subtract 4 on the left of the equals, so we subtract 4 on the right of the equals. Those 4's are eliminated. If you add 4, subtract 4, vanish. X is left, and we get a 5. Check it, put it in. 5 plus 4 is indeed 9. Put a little check. There's also a thing called the division property of equality, or the multiplication property of equality. The division and multiplication are sort of the same. This one, since the 6 is multiplying the variable, I'm going to want to divide. Usually we do the fraction more to show division these days. So divide by 6s. Multiplying 6 and dividing 6 causes elimination. Variable is left standing. 30 dividing 6 is 5. Checking it. 6 times 5 is 30. Fractions sometimes freak people out. If this is going to multiply a fraction, our job's going to be to divide a fraction. So you could either write that you're dividing a fraction, but I don't think I would do that. I would have a little 7th grade flashback and think, if I'm dividing a fraction, what do I need to do? I need to flip that second fraction that I just wrote, and I really am going to multiply. So what I'm going to do here is I'm going to multiply by 4/3. Cancel, 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 cancel. If I multiply here by 4/3, if it helps you, this is over 1. I don't care if you write the over 1. Another nice little cancel. 3 canceling 12 is 4. 2 4s is 16. So x would equal 16. If we want to check that, go back to where we had that 3/4 x. 3/4 multiplying 16. If you like, that's over 1. 4 into 16 cancels for 4. 3 times 4 is the 12 we had. That does check out. Another fraction one just to reinforce, because fractions are usually people's least favorite of our options. Again, this is trying to multiply a fraction. So we have to do the opposite. We have to divide. If we divide this fraction is going to flip. If you flipped 1/3, that's a 30. It's over 1 if that makes you feel better. We're going to multiply by 3. Cancel, cancel. Variable is alone to get 15. If you want to check that, what is 1/3 of 15? 3 goes into 15 5 times. So that checks. This is dividing, so if the variable wants to divide, our job is always the opposite. We're going to have to multiply. So we're going to multiply 3 there. We're going to multiply 3 there. A little bit of cancellation there. X would be 27. If you want to plug it in, 27 dividing 3 is 9. And that's our one-steppers. There was one thing with the variable, we just had to do one opposite. If it's adding, we subtract, and so on and so forth. If you get into longer problems, at the bottom of the notes page I made a checklist of what you want to do in terms of the order. Since we're doing opposites, the order of operations is also somewhat opposite. We're not just doing the opposite things, we have to do them in the opposite order. So this variable wants to multiply 3, it also wants to add 8. The order of operations from old days tells you to save the add or subtract for last, that's at the lowest level. But when we go to solve equations, sometimes that moves up above, multiply always moves up above the multiply divide part of the world. So with 3x plus 8 equals 17, we want to subtract the 8 to get rid of the 8's and do always the same thing on both sides. But we're not done because 3x is still there. 17 minus 8 is 9. Now we'll have to double back and deal with the 3. Since 3 is multiplying, we divide. 3's are gone. Didn't space myself enough space, but the variable will be 3. And then check it. 3 times 3 is 9, add 8 is 17. Check, that works. On a quiz with equations, you should never turn your paper in and think, I wonder how I did. You should be able to turn your paper in and say, I know I got these all right because I checked them. Or, I know I missed 2, I checked them, I just couldn't figure out what was going on in that one. But you've got to check it. This is different because there's a variable on each side of the equals. So if you get problems where there's a variable on each side of the equals, what you have to do is pick either of them and get that eliminated. So if you wanted to eliminate this, since it's a positive 6x, you could subtract 6x on this side, which would make you subtract 6x on this side. I'm not going to do that, I could, but if I do a subtract 6x, I'm going to create a negative, and most people would rather avoid negatives. Another approach, and I will do this, is try to get rid of this one. Again, since this is a positive 3x, I'd subtract 3x here. I'd subtract 3x there, and then I'll go at it. 6x minus 3x is 3x, still a plus 8, still an equals, still a 5. As a what if, If this had been a negative 3x, I would have added 3x on both sides to get that elimination going. If this were also a negative 6x, I'd have probably chosen to add the 6x, because adding a 6 would have helped us stay positive. Now it's opposite time. Okay, again, the adding and subtracting has moved up the list. We're going to add or subtract before we multiply or divide. So subtracting 8, get rid of 8s. 3x is left, equals is there. 5 minus 8 is negative 3. Be careful on your signs. Okay, so let me take a quick step to the left and do some what ifs while this is on my mind. If this had been a negative 6 multiplying, you would need to divide by negative 6. And this would be negative 6. And one of each would cause that to be a negative. Make sure the signs come with the numbers. Like if this had been a negative 3, you multiply not just by a normal 3, but a negative 3. This is a negative 3. As a what if this originally had been a negative 9, then just pay attention. Negatives times negatives, that would have still been a positive if I threw enough negatives into the problem on my what if. Well, back to here, this is a positive 3 multiplying, so I'll divide by a positive 3, divide by a positive 3, wipes out the 3's, x equals, if I divide one of each type, that's negative, 3 dividing 3 is 1, and then I can check it. 6 needs to multiply negative 1, that's negative 6. Negative 6 adds 8, that's 2. If you don't trust yourself to remember that while you do more math, write down the 2 we discovered. 3 multiplies negative 1, that's negative 3, adds 5, also 2. Since both sides turned out the same result, we're good. Then there's a big giant one. So this, we have some x's on different sides of the equals, but we also have some x's that are on the same side of the equals. So what you're going to want to do there first is combine like terms. Okay, so this and this on the same side can be combined. 9x and a negative 6x would be a 3x plus a 4. Over here, this and that are also like terms. Negative 7 with positive 2 is a negative 5, because the negative wins that contest because it was a bigger number. Minus 6x is still there. And now we shrank that a little bit. Now it's a problem of the size that we just did a second ago. We have an x on the right still and an x on the left. So if I want to wipe out a positive 3, I'd subtract 3. But if I'm subtracting 3, I'm getting into a lot of negative stuff. I think you'll have more success avoiding negatives. I would get rid of this negative by adding 6x. Do that on the left side of the equals, and I'm keeping my like terms lined up. Okay? The xy stuff is not going to affect the numbers. When I math this, there's 9x, still a plus 4, still equals a negative 5. And then again, we're looking to do the opposites, doing the adding and subtracting right away. So with an add 4, I'm going to subtract 4. Get rid of the 4's. 9x is still there. If we have negative 5, then subtract 4. A negative minus a positive, that's a bigger negative. We're to negative 9 on that. Divide by the positive 9. Whatever the sign is with the number with the variable, that's the sign you want to work with. So when x has a positive with it, we're dividing by positive. A few minutes ago, we had one of my what if problems, I think. Here it is. I was dividing by a negative, so we brought the negative with it. Back on this one, the number with the variable was negative, so we brought negatives with it. Whoever's with the variable, you bring those signs with it. So if x is multiplying positive, you're going to bring positive stuff along for the ride. 9's are gone. X is finally alone. When x is alone, that's your signal you're going to check out that you're done. Negatives, positives, one of each gets a negative result, and that's a 1. And one last check, and we'll call it quits. So if we do 9 times negative 1, that's negative 9. Negative 9 adds 4, we're up to negative 5. Negative 1 times negative 6 is positive 6. So negative 5, positive 6, grand total of 1. That's a total coincidence. We just got a 1, and this had something to do with 1. It's just luck. If we put -1 in here, -1 times -6 is +6. +6, we could go in any order, but I'll go left to right. -1 adding that +6 would be a -1. -1 adding 2 is also a 1, since both sides are 1. That's a winner. Let me grab my paper and see what the assignment is. The punch list here at the bottom too is worth a mention. Only one of our questions had like terms, which is this one. Okay? But if you have like terms, do that first. A couple of the questions ended up with a variable on each side. If you have a variable on each side, that is your next priority. Third place is add and subtract. Add and subtract we're going to take on before multiply and divide. Multiply and divide's generally the finish of the process, and then you check it. Where we are homework is page 58, working from 1 to 40. And again, I came in at the beginning saying this, I'll go out at the end saying this, you have to show the work. Every speck of stuff that I wrote on the board, all these crossed out things and lines and opposites and check marks and stuff, that's what your paper needs to look like for a day. We'll trim that down tomorrow, but for a day, the main emphasis is not as much on, for problems like the beginning, figuring out, oh, it's 11. Well, yeah, we knew it was 11. We're trying to reinforce doing the opposites, doing the same to both sides, like the algebra process, getting that like really pounded into your brain again one more time. Email me if you have any questions. We can set up a Zoom meeting if something goes wrong. Otherwise, we'll see you in the next video.